Hello, hello. Can you hear me? Yeah? So, well, my name is Jorge Sanchez. I'm going to talk to you today about how to use functional programming to improve your code. That's my Twitter and GitHub handle. So all the code that we're going to see here today is on GitHub, so you can download it and check it. First, a little bit of background. So I started several years ago working on mainframe. I don't know if anyone of you know what that is, but well, that's mainly COBOL and things like that. Then I did a Coursera course on functional programming in Scala, and I had the opportunity to start working with Scala at the same company, then did more courses with Abla Computing, and now I could consider that my coding skills are kind of acceptable, but they weren't at the beginning. So I suppose several of you are or have a background with Java development, and I suppose you've heard that don't do Java programming with Scala. So no one told me that, because I didn't have that problem. I don't come from a Java background. My problem was that I was doing COBOL code using Scala. So imagine like a big main and no classes, nothing. So after doing some courses, learning from other people that helped me get better, now I think in a better position. So in order to get a motivation to what we are going to do today, let's suppose that we work for an analytics company and we get a requirement as a Scala developer. So our business user comes and tells us, as a user, I would like to see if bad or good things are being said about Trump and where those things are being said. So this is our company's architecture, and we are required to fill that gap. So we've started doing Scala. We want to complete this requirement, so what do? We start investigating what tools are available to us. So why not maybe use Spark and Stanford Core NLP to do the sentiment analysis to see if what people are saying on Twitter is good or bad. And then we will have to send the results to Kafka, and it will be read by a Play application that will show on a front end, on a map, what is being said about Trump. So basically, this is what we need to do. Use Spark for stream processing, Stanford Core NLP for sentiment analysis, and then sync that into Kafka, serialized using Avro. And because we're using Scala, we're using Avro Forest in order to do that. So first of all, we will define our data model, which will look like this. We will create a case class called tweet. It will have an ID, which is the ID of the tweet itself, the user that sent it, the text. Of course, we need that to analyze the sentiment. And then the latitude and longitude to be able to position that in a map so our user can see where those things are being said. And the sentiment. We are using an integer here, which will have one of three values, either -1 for a negative sentiment, 0 for neutral, and 1 for positive. Then we are overriding the toString method here, so the JavaScript can parse it and show it on the map. So we don't know anything about the Spark, right? We don't know anything about Stanford Core NLP. That's all new to us. So what we do is we go into the documentation and start reading what we have to do, basically. It's just take a piece of code, put it into our IDE, take another piece of code from Stanford Core NLP examples, for example, and put it together. So we come up with this. which basically is we read from Twitter, we create a stream of tweets that contain the word Trump, and then for each one of those streams, we are only interested into the tweets that are in English, because it's the only language we can understand and we can analyze. So then what we do is extract the location in that line where we create a new geolocation. We get the latitude, we get the longitude, and we normalize it. So we convert that to the lowest integer. Then we analyze the sentiment of the text in the function getSentiment. That's what we've taken from Stanford Core NLP. Then we generate our data model using the tweet case class. And finally, we serialize that using Avro and send that into Kafka. So far so good. I think this doesn't look that bad, but there might be some problems. Yeah, so sounds good, doesn't work. So the problem here is that in the geolocation, the status type is a Java type. So I don't know why, instead of having an optional type or something like that, they like to put nulls instead. So when we try to access the latitude and the longitude, what we are doing is trying to get a null. So what we get is a null pointer exception. And the same happens with getSentiment. If the text is empty, it will throw another exception. So what we need to do now is some kind of error handling. So the Scala standard library gives us 3 different types. The first one is options. So in our case, this is the most suitable one, because if we don't have a location, what we can do is, all right, don't return null, return none, and I will take care of what I want to do with that. Then Scala provides us as well with try, which will catch exceptions within a failure, or return the result type that we want with a success. This is good if we are only interested in exceptions. We don't care. We don't have a model for the errors. But I prefer, if I have to use something to handle errors, I prefer to use either. That lets you define some different type A instead of only exceptions or throwaways or whatever. The only problem with either from the standard Scala library is that prior to Scala 2.12, you had first to project the right side and then do whatever you wanted to do with that. Anyway, if you are interested in some more advanced Scala libraries, there is CATS and ScalaSit. They both have similar types. They have either, which is similar to the one from the standard Scala library, but this one is right biased, so you can change it with other computations, do whatever you need. And then you have validated and validation that are useful to accumulate errors. So if you're trying to run different computations, what you can do is run them independently and then get back together all of the results. And if you have more than one error, you can get them with validated. So let's see how we can fix our first implementation. So the function getSentiment, what we're going to do is pass the text now. We are going to wrap that computation into a try. And because we don't really care about if there is an error, we are going to transform that into an option. That will make our lives easier as well. And then for location, we have another problem, and that is that people that is tweeting about Trump don't share their location ever. So we have to generate some random location. So we are going to try to get the location, but because normally that won't be available, and I want you to see something today here. We're going to get some random location in case there isn't one available with the tweet. Okay, so now we've changed location and sentiment a little bit. Don't try to not use get directly on an option. We are using that here because, well, we are controlling the function we are calling, and we know that whatever happens, we will always return some instead of none. So for example, in getSentiment, if it fails, what we'll do is just assign a neutral value, and that will be all. Okay, so good so far. So let's see how that works. All right. I'm going to run this from IntelliJ. So we have this. This is the front end. No. Okay. So this is the front end, and this is IntelliJ, of course. And we are going to run the process. So this will start as Spark computation in our supercluster. Then we'll send all the data to Kafka, and our front end should show something soon, I suppose, if the gods of the live demonstrations are in our favor today. Maybe, maybe not. Come on. Yeah. Something's happening here. I tested this 5 minutes ago. Or 10. It was working fine. So let me check. No. Come on. Let's try that again. I hate when this happens. Sorry about that. Let's run it again. Yeah, perfect. So, thank you. All right, so we can see here some tweets about Trump, what they say, and it is mostly bad, as we can see here. So we go to our business user, right? We saw this. Everyone's happy. So we can go and relax because all the work is done now, right? Wrong. We haven't tested this. We've just taken the code, run it somewhere, and yeah, it works, but we don't know if it is doing what it's supposed to do. So how can we test this code? Well, basically, the only way to test this is by doing what we've done, which is run it and see the output. There is no way we can take that big chunk and somehow test what is happening, right? So first, what we have to do is refactor the code. So in order to do that, we have to try and look for our business logic, what we really want to do, and separate that, take it apart from the specific of our implementation, which is basically a Spark. We don't care about the Spark. We care about what we want to do with those statuses and, yeah, basically analyze the sentiment and so on. So going back to the code, we could say that we don't care about the top part. We don't care about how the stream is created. We don't care about RDDs. We don't care about the Kafka producer. We just care about getting the location, extracting that sentiment, and returning a tweet back, right? The rest is technical details about how we are going to do that. So to summarize, we are going to filter the tweets that are not written in English, because, well, again, if a tweet comes in Japanese, I'm sorry, but we are not going to be able to analyze the sentiment. Then we are going to obtain the location. That's an important thing. Then we are going to analyze the text of that English tweet, and we are going to return a new instance of that type. And as an extra, we are going to remove that ugly Avro serialization that we have there, and we are going to put it somewhere else. And because that's an extra, we are going to do that first. So using Avro for S, it let us do something like that. We can extend some Kafka serializer that instead of us having to create all this cumbersome code in order to generate an array of bytes, whenever I want to send tweets to Kafka, I just need to create a new Kafka producer and sending them this Avro serializer of type tweet. And that will automatically, when I want to send a tweet, it will convert it for me into an array of bytes. So let's take this out of the way and see the business logic. So I've called this object business logic just to emphasize that this is our business logic, but please don't do that in your companies. Call it something meaningful like Twitter analyzer, something like that. So this is basically it. We don't care about the tweets that are in English, that are not in English. So we return none. Then we get the location. If we get a location, that is, if it's some, which will be, then we extract the sentiment. And with that location, that sentiment, and the rest of the data required for tweet, we create that, and that can be called from our RDD or wherever and sent back to Kafka, right? But this looks, this is all right because it's small. But if we start increasing the number of functions that we want to call, this starts to get real ugly quickly. So we have to use something that I'm sure most of you know already, which are for comprehensions. What we can do with the first if clause that we had before is separate that into another function, check language, for example, that will check for the language of that status, and if it is English, well, if it is, in this case, the language that, any language we want, will return that status. If not, it will return none. And then we can use for comprehensions with that. So this is, I think this is much more clear than before. I mean, this is a little bit messy. This is clear what we want to do. Check the language, get the location, get the sentiment, boom, off you go. So now it's clear what we want to do. Check the language, get the location, get the sentiment again, and we can test this. I mean, it is clear what we want to do. It is clear functions, clear business logic, and you can use, there are tons of testing frameworks, Scala test, microtest, pure test, mini test, whatever. But please use something, test your code. I've seen code bases in production without tests. I don't know how they worked, they did, but please don't do that. And let's have a look at some of those tests. So this is too big, okay, but you get the idea. Here we check the business logic, we check that, the language, we check that it returns something, and that it returns the status because it is English. So write test. For every piece of code that you write a test. Please, really. remember, when you are coding, you are not coding for yourselves. You are coding for your colleagues. You are coding for colleagues that are not even in the company. You are coding for your future self in 6 months that is going to find that code and say, what is this doing? So please write tests. This is, I want to stress this out, but this is really important. And going back here, yeah. So now we have unit tests for our business logic, but what happens with integration tests? You have to write integration tests. If you are using, instead of a Spark, whatever other thing, you are going to write different integration tests. Your unit test will remain, but the integration test will change if something else changes. So imagine that, well, you are working for this analytics company and a new architect comes in and say, all right, guys, this is nice, it's all right, Spark works, but we are going to use now Akka Streams. And you're like, why? We've done all the work now, it works, we've tested it, you know it works, so why use Akka Streams anyway? So you get a little bit upset because, well, it's a change you didn't want to make, but because we are good software engineers, we like challenges, so we want to do this now. And we realized that, well, we have our business logic separated from Spark, so maybe it is not that hard to change it. But first, a little bit about Akka Streams. So I don't know if you know anything about it, but it's composed of processing stages that are sources, flows, and sinks. Like the name suggests, source is to read from somewhere, flow to do some processing, and sink to send it somewhere. You've got output port, that means data comes out of that port. You've got input port, data comes in, and then you connect those, and you get a workflow in Akka Streams. So how would that look in Akka Streams? Well, you have to have an implicit actor system, implicit actor materializer. You have to handle several things, but basically you create a source of a status, which compared to our Spark case was the create stream. Now you create your sink as well for Kafka, and the only thing you need to do to plug in your business logic is just call this flow from function and call your business logic. That's all. So you don't have to change anything within inside your business logic. Then you put everything together, source status, via that flow and to that sink, and run it. But don't believe me. Let's have a look. If it works now, of course. Now, all the code is on GitHub. Please check it out. There might be something's wrong. So this one is number one, Akka. Okay. Well, we have one from before hanging there, Sila. Yep. Red. Come on. This should start working again. Imagine our Kafka cluster is in maybe Europe, in AWS. We have done our server in the United States. And I don't know why this is taking so long. Yeah, let's see what's happening. Maybe no one is, yeah, thank you. All right. Yeah, green one. So yeah, let's stop it here. I don't want to embarrass the president. So it works. I mean, we haven't touched the business logic. That's just perfect. I mean, our business stakeholder doesn't care about if we use Spark, if we use Akka. They just care about what it is doing, right? So why should they bother? Why should we touch the business logic? We shouldn't. So I think it's important to have those two concerns separated. Sorry. So now imagine you've got our business logic, you've got your check language, your extract sentiment, whatever, but they are doing some call to an external service or some database. So what you want to do is run those calls asynchronously, right? Because you don't want to be waiting for the data to come back. So we might want to use filters. So I don't know if you know what filters are, but there is a quote from one of the contributors to Scala that I love, which is Victor Klan, and he says, well, it represents a space, a value detached from time. It's philosophical. But what it means really is just that at some point in time, we will obtain what we need from a computation wrapped in a filter. So basically what we want to do now is wrap our calls to our functions that are calling some service into a filter. Yeah? It should be easy. I mean, we just want to run that asynchronously, right? But the problem is that it's not that easy because you are returning in those functions an option, you are wrapping that into a filter. Those are two monads, so you need monad transformers. So, whoa, chottomate, wait a moment. What is that? I mean, we are just doing four comprehensions. We are just doing very simple things, and suddenly we jump into monad transformers. We don't even know what a monad is. So I'm going to start by that question. That's the $1 million question, right? What is a monad? I have no idea. I mean, I know a monad is an applicative functor, but still, we are making things easier here or harder. I don't know. So instead of focusing on what these concepts are, which we are using every day, we're going to focus on why they are useful to us, right? So applicative functor is just something that provides us with two functions, pure map, pure to wrap a value of a given type into our container type, and map to transform that type into another type within our container type. Yeah, basically, that's it. So on top of that, monad, what give us is flat map, which I'm sure every one of you have used. And flat map basically is used to chain operations. But as you have heard, I'm sure, if you attended Gabriel Petronela's yesterday talk about monad transformer, monads don't compose. So in order to make them work, what we need is some kind of special glue to make them work together. And that special glue is called monad transformer. And thankfully, there is a lot of clever people out there that have written them for us. Like this one is from the CAT library. And as long as you have some option T, this will work. So what you have to do is wrap. I know it looks a little bit like the wrong way around because you are trying to wrap a filter into an option and not an option into a filter. But what this will do is when you access the value, is return that filter option for you. So, yeah, it doesn't look that bad. And this works. But the thing is, well, we are running our computations asynchronously now. We are calling whatever service we need. But one of the characteristics of filter is that it is an eager computation. So as soon as you declare this future or call it, it will start running. Maybe in this thread, maybe in another thread. We don't know. We don't care. But we want to have a little bit more control over when to actually run those computations. So there are different options out there. We just need it to be some monad, like Monix task or Scala set.io, that they will defer the execution until you actually say, all right, now you can start running. When I want, not when you want, okay? So how does that look with, for example, task? This is the same code, right? We just swap future with task. Instead of returning a future of option, we return a task of option. We wrap our calls into task, and maybe we can do some magic here to make it work for both task and future, and wherever we want to throw at it. And that is true, we can do. That's called abstraction over monads. So we add a level of abstraction, and what the code here is doing in the process status is just having an implicit instance of a monad of type F. So what it requires is just saying, all right, as long as the type F that you will use when you call this function is a monad, this will work. So you can use option T, and from option of that monad type that you want to wrap your computations into, and this will work. So how would that look? Like this. Process status, either task or future. If it is task, you have to call then run async or some of those functions that task has. But you can use task, future, Scala set.io, wherever you want, well, or wherever your users want to use of your library. So again, don't believe me. Let's have a look. So let's go here again. Let's see how it goes. Well, we got one hanging from B4. And we are going to run, for example, for task number 6. If this goes well, I suppose it will, but we should start seeing something about Trump again. Maybe now everything will be green. Who knows? This is kind of like a lottery. Yeah, come on. Don't let me down again. Nothing. Let's start this. Yay, cool. So it works. Let's stop it. So it works, and that is totally fine, but what did we say before? That for every piece of code, we need to write a test, right? So I don't know if you've ever tried to test asynchronous computations, but it can get messy. So now that we can abstract over any monad that we want, we can test it by using the ID monad, which is basically don't do anything. It's the unit, is empty. So this will run asynchronous, not an asynchronous, but a synchronous computation. And this will work. We will verify that the business logic does what it's supposed to do, and our colleagues will be happy with us. That's important. So I don't know if you've been paying attention to this code here, but what we are trying to do actually is just calling 3 different services, right? But we have to wait for our database or external service that is checking the language somewhere else to return and then proceed with the next calls. So maybe we could run these 3 computations at the same time because, well, we are checking the status to see if it's written in English, but at the same time we can check the status. We don't need it to be English to know the location. We only need it to be English to analyze the sentiment. And if it's written in Japanese, maybe I get a neutral sentiment or whatever, I don't care, because in the end, if it's not written in English and this computation fails, the first one fails, I will return none. So anyone knows something we can use here to run this in parallel? Any idea? We've seen it before? No? We can use applicative. So the code changes a little bit. We are not using 4 comprehensions anymore, but the good thing about applicatives is that they compose. So you don't need flat map. You just need to call this function compose in order to make an option and an instance of any applicative work together. And then you wrap, we've seen the function pure, you wrap that computation into your applicative, and if all of those 3 computations that are running now in parallel return some value, the function create to it will be called with a status, a location, and a sentiment. Again, how does this look for future and task? Exactly the same way as before. So we are changing here the name of the object, but if you keep the same object, the people that is calling you here doesn't need to change anything. So they don't care about you using applicative, monad, whatever. The way you handle your business logic is transparent for the people that is using your library. So again, how can we test this? The same way. You don't need to change your test. Your tests work the same irrespective of if you are using applicative or if you are using monad. But again, don't believe me. Let's run it. So do you have any preference? Do you want to run it with future? Do you want to run it with task? No, applicative. We are going to run it with applicative, but we have applicative future and applicative task.
Applicative future.
All right. Yeah. So number 2 here. We got a winner. Please come for your prize. Hopefully. Yay. Yay, but everything is red. I'm sorry, Trump. People doesn't like you. All right, we are going to stop this and go back to our presentation. So now, as a summary, this is what we've seen today. We've seen error handling, so that means please don't go throwing away exceptions all the time. Don't use null, use some of the types we've seen. We've seen how to increase the testability of our code by separating the business logic. We've seen how to increase the readability with 4 comprehensions. It is quite nice when you start seeing a number of steps in your code and it's easy to understand what it's doing. We've seen how to increase the reusability by using abstraction. And more importantly, we've lost the fear to monad and applicative. We just, instead of saying, ooh, those are scary terms, we now think, all right, monad, if I want to chain operations, applicative if I want to run them separately. And that's it. But more importantly, the idea behind all of this is that we've started with a piece of ugly code, and by working several times over it, we've improved it. So I want you to go back with that idea, and if you are not happy with your code, just work over it. And I think at some point, it will start to get nicer and nicer, and you can go straight to write nice code. And now, truly, all the work is done. And we can go and relax, have a nap, or whatever, a beer, I don't care. ありがとうございます. Thank you very much.